Unit 2, Lesson 6, Using Equations to Solve Problems. I can find missing information in a proportional relationship by using the constant of proportionality, and I can relate all parts of an equation, like y equals kx, to the situation it represents. So number 1, we're talking about a performer expects to sell 5,000 tickets for an upcoming concert and wants to make a total of $311,000 on these tickets. Assuming that all the tickets are the same price, what is the price for one ticket? So if I'm trying to figure out for one ticket, this would be pretty straightforward. Divided by 5,000. Now we know that this isn't a perfect universe, because if I was going to a concert, the tickets closer to the stands or closer to the stage would be more expensive than the tickets further away. But in this magical universe, they're all $62.20. How much will they make if they sell 7,000 tickets? Well, that's $62.20 times 7,000. Now remember, when you get this in your calculator, you want to make sure that when you say the number, it's $62.20, because there's two places behind the decimal in money. Same problem. It says, how much will they make if they sell 10,000 tickets? How much would they make if they sold 120,000 tickets? Now we're getting into the millions. How much would they, if they did 50,000 tickets? How much would they make if they sold X tickets? Well, every time, if you think about it, I've taken $62.20 and multiplied it by the number of tickets sold, right? Every time I said $62.20 times the number of tickets sold. So that means it's going to be 62.2x. And when they're touching each other, that tells us it's multiplication. So if they make $379,420, how many tickets have they sold? Well, now I'm going backwards, right? And I'm using the amount of the cost of the ticket. So $62.20. Remember, this is a magical place where all the seats cost exactly the same and everybody gets the best view in the house. So that's 6,100 tickets. What if they make $5 million? Remember, that fraction bar means to divide. So I have to round this number because it's a number of tickets, and I'm actually going to round down because even though it's 0.85 when I get my answer, so it's 80,385.85, I have to round down because I can't sell a new ticket because I won't have made enough money. So then it says, aluminum garbage. A family threw away 2.4 kilograms of aluminum in a month. How many cans did they throw away? Explain your reasoning. So we know that 10 aluminum cans is 0.16 kilograms. Okay, so if we know that's cans, right? And that's kilograms. I want to figure out what 1 kilogram would be so that I can figure out what 2.4 kilograms are going to be. So I divide by it's a little too high. Divide by 0.16. So I have my calculator, and I'm going to do the same thing on the other side. 10 divided by 0.16, and order really matters. So it's 62.5. So 62.5 cans are 1 kilogram. So if I wanted to get from 1 to 2.4, I'm going to multiply by 2.4. Same thing on this side. And I get 150. So how many cans? 150 cans. What would be the recycled value? So now I know that I'm doing cans and money. I know 10 cans will give me 14 cents. So if I have 150 cans, what would that be? So I'm multiplying by 15. The reason I'm not finding for 1 in this example is because I know a number that I can multiply 10 by to get 150. So 15 times 14 cents is going to give me $2.10. So that's my final answer. So then it says, write an equation that represents the number of cans C and their given weight W. So I know that I have, I'm looking back, so I know that for one kilogram, because remember every time we're looking at that constant of proportionality. So to find out the number of cans given their weight, I would need to do C equals 62.5 W, because it would be their weight times that number of cans is going to give me a total number of cans. So then it says, write an equation that'll give the recycled value. Write an equation that will give the recycled value of our cans. Well, again, I'm going back. So if I know that I have to find for 1, I would divide by 10, divide by 10, and I end up with 0.014. So for 1 can, it would be not even a whole 2 cents. So it's going to be the recycled amount, the amount I get for recycling, is going to be not even 2 pennies per can. So for every can. So then it says, write an equation to represent the recycled value R of W kilograms of aluminum. So I know that the recycled value is going to be 0.875 of the weight of the can. So the weight of all the cans together times this is going to give me my recycled value. So practice problem 1. A car is driving down the highway at a constant speed described by the equation D equals 65T. So it tells me they're going 65 miles per hour. D represents the distance and T represents the time in hours. So what does 65 tell us in this situation? That tells us 65 miles per hour. So that's our constant of proportionality. So it says, how long does it take the car to travel 26 miles at this speed? Well, distance in miles is going to be 26, and I know it's 65 t. So if I'm multiplying by 65, in 6th grade we learned we had to divide on each side so that we could get the variable by itself. So then I take my handy dandy calculator, and I'm going to go 26 divided by 65, and I get 0.4 equals t. Well, that doesn't get me a final answer because I still need to figure out how much time is that. Well, I want 0.4 of an hour, right? So if I'm thinking about an hour, and I'm thinking about 4/10 of an hour, what would that be? So there's 60 minutes in an hour. So I would multiply by 6, multiply by 6. So that gives me 24 minutes would be an equivalent ratio to what I have now. So my time would be 24 minutes. Okay, how many miles does the car travel in 1.5 hours? Well, I've got D equals, thinking about the last problem, D equals 65 times 1.5. So then I just take my handy dandy calculator, 65 times 1.5. So the distance is 97.5 miles. Practice problem 2. Elena has some bottles of water that each hold 17 fluid ounces. So write an equation that relates the number of bottles of water B to the total volume of water W in fluid ounces. So right here we're trying to think, okay, what's happening here? So they want an equation. Elena has some bottles of water that each hold 17 fluid ounces. So 17 is going to be my constant of proportionality. So the total amount of water is going to be 17 times the number of bottles. So they want to know how much water is in 51 bottles. Well, I take 17 times 51, and then I take my handy dandy calculator, and I get 867, and this would be ounces. So the total amount of water in 17 bottles is 867 ounces. Okay, so how many bottles does it take to hold 51 fluid ounces of water? So that'd be 51 equals 17B. So again, we're going to have to divide by 17 to figure out how many total bottles. So I know that that's 3 bottles. Last practice problem. There are 1.61 kilometers in a mile. Let X represent the distance measured in kilometers and Y represent the same distance in miles. Write 2 equations that relate a distance measured in kilometers and the same distance measured in miles. So I know that this is my constant of proportionality. So I know that X is going to represent kilometers. So I know that I would have to take this and multiply it by the miles to get the number of miles to get the total number of kilometers. So I'm going to go with X because this is the number of kilometers. The total number of kilometers is going to be 1.61 times Y, which is the number of miles. I like using the letter that starts better than X and Y, but sometimes you have to do what the problem says. So now they want another equation, so I have to reverse it, right? So I have to do it backwards. So I'm going to have to use the reciprocal. So now I've got y equals 1 over 1.61 x. So where this one is the number of miles. And that is the number of kilograms, or kilometers. So all I did was use the reciprocal of the constant of proportionality. So now you have a cool down image. You need to go ahead and do your cool down. We've been writing all over our keynote, so you should be writing stuff down to do your cool down. If you need any help, this is how you would submit. These are the resources you have available. And if you want to make an appointment with me, sign up on Calendly.